Welcome back to CAD/CAM tutorial. Today we are going to design and assemble a feed check valve. This is actually a part of boiler which controls the flow of water from feed pump to boiler and further prevent the backflow of water from boiler to pump when the boiler pressure is more than the pump pressure or when feed pump stop working. So here we will make all the parts and assemble at the end. So let's make this pump valve in SolidWorks. Now here the first part is body. Now this is the assembly of feed check valve. See, there are all the part listed in this table. Now first part we are going to start body. Okay, so let's check this section view. We are going to start with this section view. See, there is a center line. This hollow part is going to be hollow, and this shaded parts, it's a solid part. So you will see the first diameter 108, this last diameter 206, then this wall thickness 12, inside diameter 120. Just note down these all dimension. Then come down 108, and this is 80. This is the 88, 80, and this thickness 12. Here also shows thickness 12, and okay, 16 this thickness. Here this thickness you will see 20. If you okay, this 10.5 this side, no, we are not going to make this one. 12 this already shows, 12 this also. So first we have to choose a plane, even though you can change unit directly from here. Background you can change from here, so I'll keep plain white. Front plane is sketch. Now I'll activate center line. First I am going to create a center line. Right click, exit. Now start line. Now let's say I'm going to start from here. Okay, now let's go, and don't try to create any relation, otherwise it creates difficult. Exit. Now this is close. Now activate smart dimension. Now first let's define the vertical length, and that is according to drawing 16 plus 35 plus 40 plus 140 plus 20. Enter. This is 251. Now select this one, hold click this line, construction line. If you move out, and you will see the diameter. If we keep inside, you will see only radius. So I'll move outside. 180. Not 180, actually it is 108. Now if you choose out this line, outer diameter 206, this one 80, 88, and the center one 128. Say yes. Look. Now let's define this, shift key, and only define this. Ten, 20. Now this gap, it's 12. Look, it's going to define. This is 16, the last one. and distance from here to here, this one 16 plus 35. Okay. Now this from here, this is 16 plus 35 plus 40. Enter. That's it. Now just drop down this. Now activate smart dimension. Now these gaps also 12. We forget to add some more here. Delete. Delete this line. Now connect. Now let's make vertical. Delete. Okay. Smart dimension. Now this is going to be 12 and this is going to be 16. Okay, it's already defined. Now this distance from center line, diameter 206, escape 12. Similarly, the distance between these 12. Now look, the drawing is fully defined. Activate revolve boss base. Now here axis of revolution, I am going to choose this center line. End condition keep blind and angle 360 degrees so that we will get a solid, full complete solid body. Rest keep as it is, say yes. Deactivate real graphics view so that you will get a perfect view. Now let's make this solid part 96 diameter. Now from this end to center, distance from bottom 140 from here to the center, and if you see here 130 plus 16 plus 16, then there is a hole 75, this is throughout hole. Then there is one flange also 206, this flange thickness 16 but 15 millimeter away from here. So let's try. So let me choose here front plane. Now front plane and distance here 130 plus 16 plus 15. Okay, but this is moving wrong direction, so flip. Okay, axis. Now draw a circle, activate circle, and this diameter it's 96 millimeter. And center distance from bottom edge 140 is still not defined. So hold shift key, select this center point and center of the circle, vertical relation. Just rotate and you will see. Now here choose extruded boss base. Now start condition is plane, end condition I am going to choose up to next. Up to next means it's going to focus on this body. Merge result, say yes. Let me hide. Click and hide the plane. Sketch. Now again let me draw one radius is 206. Okay. Now let's extrude, but here little twist. End condition depth is how much? 16 millimeter. Reverse direction, but this is 15 millimeter away from the plane, so I am going to change start condition, offset 15 millimeter away. Still this is moving downward, reverse direction. Now look, it is moved 15 millimeter away from this plane and 16 millimeter is thickness, say yes. Look, hole wizard. Click here, hole, metric, just drill, and the section, custom section, and 75 millimeter is the depth. Don't choose through all, choose here up to next. Even though you can choose it from here also, but let's say 75, we already choose. Customize our hole, position, select this face and move cursor and you will find center point. Even move cursor near edge, you will see a center point. Click escape key to out. Look, now let's look close view, say okay. Look, this is hole is created. Section view, front, okay. Look, now here we have to change one thing. This is 12 millimeter and these corners also shown here 12 millimeter. This width also shown 12 millimeter. I just changed the drawing. Now there is a corner radius. See this 10 millimeter. This inside, this is 12 millimeter, this is inside 10 millimeter. Okay. Now inside here also 10 millimeter, outside 10 millimeter, 5 millimeter, this is 5 millimeter, here 3 millimeter, this is 10 millimeter, and this side shows here 12 millimeter. Then we will make this rib R30. I'll show you how. Fillet. Now 10 millimeter, it's before going to check fillet, just open and check this sketch. Now here double click 12, enter. This is little change, say okay. Fillet, keep constant size fillet, symmetric radius here 10 millimeter, and we are going to choose inside. Full preview, choose here. Now select this also 10 millimeter. Now inside this also going to be 10 millimeter. This one we will make later. 10 millimeter. Say okay. Now there is no radius inside, so just simply fillet 5 millimeter constant size, and this inside radius 5 millimeter only. Edit feature. Now parallelly choose the outside edge, This is also 5 millimeter. Now uncheck section view, fillet, 10 millimeter, choose this outside edge, say OK. Fillet 3 millimeter, this corner, OK. Again activate fillet, and this time the biggest radius 12 millimeter. This side 12 millimeter, and this edge also 12 millimeter. Say yes. So we applied fillets in all body. Now there is a one thread. See, pitch 152. This is the position. 6 number of threaded hole, 15 diameter, 17 depth. This is the our threaded hole, M16 into 1.5, and here this is the standard of thread depth. 15 is the thread depth. So let's see how we will do this. And then there are 6 number of things. Similarly, at bottom there is a hole also. See, 152. These are the hole. 6 holes, diameter 6, PCD 152. PCD means the center distance. Okay, 6 diameters. But in this condition like this, and in bottom face it is like this, means this position is similar to this one. Hole wizard. Now here you have option straight tap, keep customize value, metric, tap the bottoming hole because we are going to make a tapped hole. Uncheck this one. Now that is M16 into 1.5. So here you will see M16 into 1.5. Now depth, blind. Now choose this one. Now depth is 17, hole depth 17. See, shoulder. Now thread length 15. Now here with thread call out, we want this cosmetic thread here to show. Position, select this face. Now we have to make a parallel like this. So press escape key, activate circle tool, draw a circle, click for construction, activate smart dimension, 152, enter, say yes, escape key to out. Now click this point and you will activate tool. Now place here, escape key to out, say OK. Now if you can't see cosmetic thread, just go to option, documents, property, detailing, and here you will find shaded cosmetic thread. Just check the box, say OK. Now look, circular pattern. Now you have to choose axis or any circular edge, so I am going to choose this one. Number of things, here choose equal spacing, 360 degree, and number of holes 6. Look, feature already selected here, this hole. That's it, no need any other direction, say yes. Look, now let's check hole. Now this time I am going to choose hole, drill size, hole, let's say ISO. The hole size is 16. Okay, choose next. Position, select this face. Now here activate this view so that we will get the idea. or escape key to out. Again here activate circle tool, draw a circle, click here for construction, is smart dimension, the pitch 152, activate, select this point and place this point at circle, escape key to out of this circle. Now you will see the preview. Let's change this one. See, now see the hole is created, circular pattern. Now for let's direction, let's choose this one, 6 number of patterns, 360. The hole here feature already selected, say OK. Look, now similarly going to apply for this. Now everything keeps same, hole, ISO, drill site 16 up to next. Go to position, select this face, escape and choose circle. If you uncheck this shaded cosmetic, I'll show you. Uncheck, so you will simply did not see any shaded portion here. For construction, activate smart dimension 152. Now click point and you will activate the tool. Now place at this, no, according to drawing it is like this, escape key to out, say yes, circular pattern. Now let's choose one circular edge, equal spaces 360 degrees, 6 number of holes we need, and here the feature is what, this hole, so we selected here, rest as it is, say OK. That's it. Now let's add front plane, no, right plane, sketch, line. Go back to the point and connect up to this point and little extend. Why extend? Because this is circular edge. It's difficult to create a rib on circular edge. So always try to little, now I am going to little downside because we want to cover this whole area in this face. So let's say this one 30. Now if you want to define some dimension to this, then better, so that your geometry will be fully defined. That's the advantage. Now see, this is fully defined. Go to rib, thickness of rib 6 millimeter, center one. Now look, arrow direction, it's going downward, say yes. Look, according to drawing this is 12 millimeter. Click and double click and here directly choose 12. See, it is change. Again right plane, sketch, line, come from here to this point, go back to the point and it is converted into arc. This point and let's say like this, let's define this point. Okay, these points are defined coincident with this, so delete this relation. Now activate smart dimension tool and define this 25. And for a define this upper post, even though no need, but just to define our geometry, fully defined sketch. And you must keep inside because these are the circular edges, so difficult to create. If you will not do this, it's difficult to create, even you will see some error. Rib, arrow goes downward, here choose 12, flip material side, say OK. Look, now there is a little change. This hole is lies with this, so we will change the second hole, edit, position. Now this one we will move, escape key, activate point and move here. Say yes. See, this is change the position. Now edit appearance. This is going to be our section view, right side, say OK. Now look. Now there is a last rib. Now this one 100 radius, thickness 12 millimeter. This is the last rib. Now let's go to right plane, sketch, activate line tool, and I am going to start from this line because up to this point and convert it into arc. If you can't, just simply go to activate 3-point arc, connect from here to this point. Now again choose line and move little inside because this is curved surface. It's difficult to create. 100 millimeters, say yes. For drawing definition, just define something to this edges so that our drawing will be fully defined. See, rib, arrow moving outside, flip, keep both sides, 12 millimeter is the thickness, just move, OK. Look. So this is your first part. Save it. Just go to desktop and feed check wall. This is part 1, body. Save. Let's do the next part. Now here the next part is cover, and the main diameter of this cover is 206 outer diameter. See here. And if you see section view, there is a one depth 5 millimeter and the diameter of this depth 102 millimeter. Similarly, this flange depth 16 and overall length 120 from below the depth. Then there is one more depth 10 millimeter, diameter 108. Then one more depth here, this corner diameter 88, fillet R5. Then comes down here 44 millimeter. Front plane. Now let me activate. Okay, directly we can go with now just come down little. Okay, connect with this. Escape key to out. Now make this center line construction so that we will get drawing easily. Now this one, click center line, move cursor out and you will see diameter 206. Similarly this point 44. Now this point 108. This is important. Now the next inside one 102, say here yes. The last one 88. Okay. Now let's define the depth. 5 millimeter. Select this depth. 16 millimeter, say yes. Now this depth 10 millimeter, say yes. Now the overall depth from this corner to here, it's 120. Look, our drawing is fully defined. So go to feature and activate extruded boss base. Now this is due to this construction line, it is not closed geometry, it is open. So it is system asks you, would you like to close? Say yes. Now see axis of revolution, it already detected this construction line here. End condition blind 360 degree, say yes. Now let's make inside a hollow part 44. This diameter also 44, 33 width. This width 22. Then if you comes here, you will see 33. 33 is the angle for this and center distance 32. Now here 25 into 1.5 is the pitch. 25 major diameter because this is inside, so minor diameter will be 23.5 if you are going to calculate. 20 and 30 is the depth. So okay, let's say front plane sketch. Now let's activate center line. Let's say like this. Don't create any relation. Connect. Now here choose these all lines and come down here, uncheck this construction so that it's become solid. If we choose 44, (44) 32, 22, and this is going to be 25 minus 1.5, it's 23.5. Okay, and distance this length 38. Okay, now let's make this perfect. Hold shift key, angle, select this line and choose this point and you will see trades. I'll choose this one and this is going to be 33 degree. Similarly, I'll choose this and I'll choose this point and select this trade 33. Let's select this 33. See, this is seems fully defined sketch. Okay, now the distance between these 2 points 20. Okay, now our drawing is fully defined. Simply go to feature. Here choose revolve cut. Would you like to close because this is construction line? Say yes. Now this is detected by system and it took line of axis, this construction line, 360-degree blind end condition. Say yes. If I am going to choose section view, front view, section, okay. Now look, the hole is created. Now let's make here cosmetic thread, because this is threaded part. So you can choose here view, insert, annotation, cosmetic thread. Now here I'll choose this edge, standard, let's say metric, machine thread we want to make, and this is going to be DIN standard actually, 25 into 1.5 up to next, that's it. Say OK, edit, go to option, documents, property, detailing, check the box shaded cosmetic thread. Section view, look. If we go to evaluate, measure, and if it's check this diameter, this is 23, but the major diameter is here. Okay, let's do our next thing, fillet, constant size fillet, and the radius is 5 millimeter, and I'm going to choose this inside. Say OK. Now 76 is the pitch for this. If you comes here, there is a threaded hole, 8.5, this is M10 into 1.5, thread depth 15 and the hole depth 18. See here, thread and hole depth both shown. Then there is a hole, 6 diameter throughout 6 holes. See the position, 152 is the pitch for this. No need to sketch actually, exit and simply go to hole, click here hole, metric, drill size, show custom, and here directly put your hole. Even you don't need to search the what diameter you want to choose from here, simply put here. End condition next, how long we need to expand or make the hole. So keep end position, select this face. Before going to place, just simply escape, activate circle tool, click something like here or somewhere like. For construction, activate the smart dimension, 152. Now again activate point. Now place here something. Okay. Now escape key to out. Yes. Circular pattern, activate circle. Now here you need to make direction. So either you can choose axis or any circular edge or face. So I am going to choose this face. Equal spacing 360 degree, 6 number of holes we'll want. What is the feature? This hole. So it's already selected. Say yes. Now again let's go to hole wizard. Now choose this one, straight tap, keep customize metric, tap the bottoming hole. Now here you have to define the thing, M10 into 1.5. This is M10 into 1.5, uncheck this customization. Now here keep blind. Now depth of the hole is 18. We already almost keep shoulder depth up to shoulder, not thread. thread depth you have to define 15, that is. Okay, we want with cosmetic thread, so check this box, position, select this face, activate first circle. For construction, activate smart dimension, and this depth 76. Okay, now activate this point and activate the tool and place something like here and one point here. Escape key to out. Say OK. Let's check front plane, section view. OK. Look, the whole, see, this is 18 depth but thread only 15. Now let's save this part. Part 2 is cover. Let's check the next part. Third part is hand wheel. So see this section view. This circular diameter 24. Then the height of this 26, depth of this diameter of this 26, and there is a hole 12 diameter. Okay. Then there is one circular edge. If you see here, this circular radius R4. Once you create this, then we will create this fins. This is elliptical type 12 by 8, and there is a corner radius R1.5. So let's see. Front plane sketch. Now I am going to draw one construction line. Escape key to out. Activate circle tool. Smart dimension. Now these diameters are 24. Click this. Now diameter 140. Line. Now here go back to the point and see it is automatically converted into arc. Draw a half circle. Now select, shift this point and this line, merge. Okay. 26. 12 the diameter for this, and this diameter 26. Radius 4. Say yes. Now what else balance? Okay. Hold shift key, select both the lines and center one and leave, and you will see this option pop up, symmetric. This is fully defined sketch. Revolve boss base. Now here you have to choose axis of revolution, so I am going to choose this one. Now look, blind condition 360 degree. Look. Now right plane, sketch, ellipse, smart dimension. Now this width 8 and the length 12. It's still not defined, so make one relation. Hold shift key, center point and these 2 points. Now this is fully defined sketch. Now this is little tricky, I'll show you how. Extrude. Now first start condition. So I'll choose surface. Let's say this surface. Now you will see there is an embossed mark. Now this is going to start from this plane, not from here. Even though we can choose, but let's do something different. We will start from here up to surface. Which surface? I'll choose this surface. Look, I am going to start from here and up to this surface. This is the beauty of the SolidWorks. Say yes. Look, circular pattern, circular edge, let's say this inside edge, 360-degree equal spacing, 6 number of this solid part we need to make. And what feature? So we already selected here by default. Say OK. Fill it. 1.5. Now let me choose this all edges. Now select all these corner edges. Radius 1.5, symmetric, constant size. Say yes. Edit appearance. Say OK. Now let's save this one, the third part. Hand wheel. Now here is the fourth part, valve seat. Now this depth 6, height 40. Now this outer diameter 102, 45-degree tapered, 3 millimeter of this tapered, 75 and 88. Now click front plane sketch. Now let's activate line tool and let's directly OK. Now make one relation horizontal. Now let's define, even we need center line. So now the outer edge, outer diameter 102. Now this diameter 88, 75. OK. Now let's adjust this. Now these, click this point, this trade, 45-degree. 3, 6. Okay, let's make this height 40. Now this seems fully defined. Go to feature and choose revolve boss base. Now axis of revolution already detected by system. Full round body we want to make. Blind condition 360-degree. Edit appearance. Okay, let's save this part number 4. Valve seat. Here the part number 5 is valve. See, this is a kind of valve. First we will make upper circular faces 32, 88. Then there is a chamfer 3 into 45-degree. This depth 6. Then there is a chamfer 3 into 45-degree. Then there is a 4 lobes. See, in hidden line, 43 from here to here. 6 millimeter is the depth, 74 is overall length, and this 45-degree seems 4 millimeter. So let's make this front plane sketch, activate line tool, and I am going to start from here. Little taper, exit. Make sure construction line so that it's easy for us to do dimensioning. 32. Similarly check outer one. 83. Okay. Now 6 millimeter. Now select this one and select this end point and 45 degrees. So I'll choose this one, 45 degree, and height 3 millimeter. Smart dimension, let's define this 3 millimeter. Now see the drawing is fully defined. Activate revolve boss base feature. Would you like to close? Say yes. Because of this construction line, it is automatically detected by system 360 degree. Okay, again let's front plane sketch. Now activate, start from mid and connect something here and connect. Smart dimension. Now distance shows from here to here, it's 43. Say yes. And see, if you put this solid line, you will not get the diameter. So you have to put radius. So 74 by 2, it's 32. Okay, these diameter 40, corner radius, and 4 millimeter is the width. Now here I am going to choose extruded boss base. Now keep end condition mid plane, depth thickness 6 millimeter. Just check. See, it is moving in both side equally. 3 millimeter one side, 3 millimeter other side. Say yes. Circular pattern. Now here choose direction. So I'll choose this circular edge. Now here I am going to choose 4 number of instances, 360 degree, feature already selected. Say yes. Look. Part number 5, valve. Part number 6 is gland. See the top face, 25 R13. There is a 2 hole at 75 millimeter. This hole diameter 10. And the depth of this flange 13. Then there is a vertical cylindrical 44 diameter, 44 length. Then there is an inside hole 22 and 33 degree. So we are going to start with top plane. Sketch. Activate construction line or center line. Exit. Now activate line tool. Now activate line and connect this line to this line. Now make sure this is tangent to this. Activate smart dimension. Now this is radius 13, means diameter should be 26. This radius shows 25, 50. Now the center distance 76. So select this point and this 76. Look. Mirror entity. Now let me choose this one, mirror about. Even here choose this line also. Make sure you selected here copy. Mirror entity, and I am going to choose these two lines, mirror about this line. Trim entity, power trim, just trim these lines. Still the drawing is fully defined. Extrude. Now this is going to be 13 millimeter. Let's make downward. Cancel, normal view, activate sketch. Now let's add two circles. 10, hold shift key, select both the circle and make relation equal. Activate smart dimension, diameter 10. Now activate extrude 13 millimeter, downward direction, say yes. Look, select backspace, sketch, activate circle and diameter 44 and extrude, and this depth 44 millimeter and condition towards downward blind. Now let's activate front plane, sketch. Let me choose line, construction line. We want to cut a hole. How? Now select this line, select this point. Now select this one, 30 degree. Now outer diameter is 22. And this is going to connect with this point. Hold shift key, select these two end point coincide. So our drawing is fully defined. Activate revolve cut, say yes, because this is open geometry because of this construction line, but by default it is selected axis of revolution and condition blind 360 degree. Front section view, okay, look. Okay, now let's save this. This is the part number 6, gland. Now here the part number 7 is spindle. Now here we have thread in two portion, M25, M10. So this is a kind of bolt. So the diameter M25, it is the outer diameter, so it is major diameter, depth is 1.5. So let's apply this. 10 millimeter is the head, 32 diameter. Then there is a inside 22, this one, and this is also 22 3 millimeter. 178, 50, 24, 15, 14, 24, and this is 12. Now this one M10 into 0.05. Front plane sketch. Activate line tool and start like this. connect. Select this line construction, so it makes easy for us. 14, 24, 10, 3, 50. Okay, just expand this more. Now again activate dimension. Now this is going to be 178. Now select this one and select this 32. 22. Similarly for this 22. 25 comes here. 12. And for this 10. Now this is fully defined. Go to revolve, activate revolve boss base, say yes to close the geometry. Line of revolution, axis of revolution selected by system. 360-degree blind condition. Look. Go to insert, annotations, cosmetic thread. Now choose first edge. So I'll choose this edge. Now choose face. So I'm going to choose this face. Machine thread M24 into 1.5. See, this is minor diameter going to be, and here keep end condition up to next. Next means the end of this face. If you click show type, it will show you machine thread while you are going to make drawing. So I am always trying to unchecked. Say OK. Option, documents property, detailing, check the shaded cosmetic thread box, say yes. Insert, annotation, cosmetic thread. Edge, I am going to choose this edge. DIN machine thread M10 already defined. This is minor diameter. Up to next. Say OK. Let's define the yellow color. Part number 6. Actually, this is 7 in our system, so a spindle. Now here the part number 8 is stud M10 into 0.5, 76 length. There is a two type of thread, 32, 18 millimeter length, M10 into 0.5. Chamfer 0.5 into 59 degree, both side. Front plane. Outer diameter 10, so activate circle. 10. Extrude 76 millimeter long. Keep end condition blind. Chamfer. Now chamfer is 0.5. Now here degree 59. Now select both the endpoints or both the faces, or even though clear, select the face. OK. Insert, cosmetic thread. Let's hide this, and we will apply first cosmetic thread, then we will apply chamfer. DIN standard machine thread M10, M10 into 0.5, blind. Now the first one is 32 millimeter long. Say OK. Activate. Go to option, documents, property, detailing, shaded cosmetic thread. Say OK. Insert cosmetic thread. Select this edge, M10 into 0.5. Now blind condition 18. Start face also. Okay, let's check start face, this one, so that if you check, there are two cosmetic thread. Here also let me choose, this is start face. Okay, now apply. See, go to appearance, metal, let's say brushed, say part number 8 stirred, and this is M10 0.5 mm. Say OK. Stirred M16 into 1.5, length 52 millimeter, thread depth 22 and 15 millimeter, and there is no chamfer. Front plane sketch, activate circle, outer diameter M16, a 16 diameter. So because this is bolt, so always keep outer diameter as max. (52), keep end condition blind 52 in one direction. Say OK. Insert annotation cosmetic thread and choose this edge, face. See, DIN standard machine thread M16 into 1.5, depth 22, the first one. Say OK. Option, documents, property, detailing, shaded cosmetic thread. Again activate, insert annotation cosmetic thread. This edge, this is the face, M16 into 1.5, blind 15 millimeter. Refresh, edit, brushed steel, save. Now this is the part number 9, M16 into 1.5. Now we finished all the part. Let's start assembly. Bolt nuts we are going to take from system. Now here let's start the assembly of feed check wall. Click, select here assembly, say OK. Now by default this window pop up. Now just go to your folder, feed check wall. You can change large icon, body, open. Now see, you can place anywhere, just drop down this eye menu visibility, check here view origin, unchecked, and move your cursor near this and see it is going to fix. Click and leave, unchecked. plain white. If you right click, this is asking you float, means this body is fixed. Okay, this body is fixed with origin. So let's start with few more relations with this. Insert. Now here open part 2. Seat, wall seat, okay, just place here. First let me fix with this mat. Select this hole and this concentric relations, say yes. Now select this hole and this hole, because concentric relation, say yes. These holes should be parallel to this. Select this face and this face. Coincide relation, say yes. Now let me move here. Now here right click, customize tab, even though standard view, isometric drag, okay, select isometric view, that's it. Section view, this is going to hide, so okay. Now drag this, select mat. Now select this outer face and this face. Concentric relation, say yes. Now this is going to sit to this wall. Select back surface and this surface. Coincident relation, say yes. Okay. Now insert this one, control key, this one, open. Uncheck section view, rotate this one upside, okay, mat. I'll choose this face and this. Concentric relation, okay. Back face of spindle and top face of this, concentric. Now one more relation, valve. Choose valve front plane, come down, spindle, control key, front plane of spindle. Click mat. See a relation going to keep coincide. Now it is going to rotate with this. I'll show you how. Select this one, concentric relation, okay. If you see section view, okay. Now this is going to fix with this, so let's uncheck. Now let me save, rebuild and save. Feed check wall, assembly of feed check wall. Insert component, gland, open, mat. I'll choose this hole and this spindle. Concentric relation, okay, but it is moving like this, so we want to fix. Select this and this hole, it is moved, concentric relation. Select this face and this face, and here choose distance 39. Click somewhere outside, okay, cancel. Now this is fixed at the distance of 39, So this distance we are going to maintain. I'll tell you why. Okay, this is still moving. Handle, open. Coincide, select this one and this. Concentric relation, okay, just move upside. This face and this face. Coincide relation, okay. Now this is fixed here. Now let's apply some more relation with this. Spindle front, okay, sorry, hand wheel front, spindle control key front, met. See, this is going to be parallel together and make coincident relation. Say yes, okay. Now see, if you are going to rotate both, everything, these three parts rotate together. Look, just save. Insert. Now here let's click this stud. Okay, let's define the relation between height. Even though, let me hide this also. Mat, go to here, mechanical, and this is a kind of screw. Choose here screw, select this one and this one. Now revolution per mm, 1 revolution per mm, this is going to be the reverse. Say okay. See, just drag this. Now valve seat show. Now make one relation, important relation actually. This is going to be sit here. Concentric, select this edge and this one. Coincide, okay. Now evaluate, measure. Now select this face. No, not this face, because select this face and this face. Now center distance 15 millimeters. So we have to apply a limit to this. Now here we already applied. Now this mat suppress, because we know the distance. Mat, advanced mat, select this one. Now let me choose one and this. Max 14.8, 0.2. See, there is a small gap. Okay, the gap, let's say 0. We will not keep any gap. say OK, cancel. Now let's move this. See, it is not going to move beyond this, even though no backside, no upside. See, I move my mouse in both direction. See how the wheels are rotating. So basically, if you rotate, it's going to fix on the perfect position. Let's down. OK. Show. That's it. Save. Now this one, let's keep OK. Save. Now let's activate matte. Standard matte. Just select the inside face of this hole, and this inside face is tapered. See here, and select this face. Look, it is going to be coincide. Say OK. Now cancel. Hold Control key and copy. Activate matte tool. Now similar we will apply for this second hole. Select the bottom of this hole. Rotate. Say OK. Cancel. Now in drawing you will see there is a hexagon nut ISO 304 M10C, and similarly 304 M16 also there. Go to tool, ISO standard, just go, double click, nut, hexagon nut, and this is the bolt. So how to fix this? Just drag this to this and move cursor near face. M10 cosmetic. Say OK. Similarly, select here face. Similarly, move cursor here. You will see the symbol center. If you move your up to center and face, click. Escape key to out. Now here you have to create some relation. Matte, this face and this face, coincident relation. This face and this face, keep parallel. OK. Now let me insert our last stud. OK. Now let's rotate. Now here just go to evaluate, measure. Now check the distance. Where is the distance? Center distance 48.5. Clear. go to mat, select this, first make concentric relation, okay. Select this face and this face. 15. Reverse. No, not this reverse. Let's say minus 15. Flip dimension, okay. Now look, that's perfect, okay. Go to hexagon, okay, let's mirror this better option, copy with mats, or even though you can choose here circular pattern, component this, circular pattern, let's say this, equal distance 360, 6 numbers, say okay. Look, drag bolt, M16 cosmetic thread, okay. Similarly, copy with mat, component, next, this one, this face, see copy here, say okay. Now select this face and this bottom face, see both selected here, say yes. Now concentric, first I'll say this bolt, then second face, select this cover face and it's fixed, yes. Bolt, face, yes. Let's check the last one, bolt, face, yes, cancel. Now here we fixed all the bolts and everything. Save it. Now here let's make exploded view. Click exploded view. Now first I am going to select the bolt and drag in upside. Done. Wheel, drag, done. Select these two bolts, drag, done. These two bolts, done. Done. Now let me select this all hexagon nut. Done. Now similarly select this stud also. Select done. Now let me choose this, drag, cover, done. Body let's little down. No, this step undo. Delete body. Done. Select inside part. Drag upside. Done. Select inside of seat wall. It's done. Done. Right click, collapse. Right click, animate, explode. Look. Play. Now here we selected playback mode loop. If we choose vice versa, cancel. Collapse. Save. Right click, go to toolbar, motion study. Simply animate wizard, explode. Next. 11 seconds 0 start time. Finish. Again click animate, explode, collapse. Next. 11 minute start time 11. Finish. 50. Calculate. That's it. Don't forget to share and like our video, and please subscribe our channel for more video and more projects in SolidWorks. Thanks for watching.